So in the previous video, we were actually looking at the locus of the body center of antipedal triangles of a family of rotating equilaterals. Here's the family with respect to a point P, and we saw that when P was actually on the incircle of the medial triangle, and this circle is also known as the Spieker circle. So the incircle of the medial triangle, the center of the incircle of the medial triangle is the Spieker center, and this circle is known as the Spieker circle. But since we're talking about a family of equilateral triangles, all the triangle centers of this family are on the centroid, so the Spieker center x10 is on the centroid, so it doesn't make much sense for us to refer to that. But I actually wanted to show you guys the fact that when P is here, the locus of the body center over the family is a parabola, right? So here's a parabola, and in the previous video I wasn't drawing the focus of that parabola, and here it is. Now I know here's geometry playing being kind of nagging with us. I wish that this focus was exactly on the circumcircle family, but it's not. It's slightly out, slightly further out than the circumcircle. If I move P around, you can see that now this focus is actually tracing a circle that is slightly, whose radius is slightly larger than the circle radius. Okay, so geometry here didn't contribute with this particular harmony, but let's say this is a nice result nonetheless. Okay, now the main thrust now is for us to investigate the locus of other triangle centers of my antipedal triangles, right, over this family. So here's my antipedal triangle. If I move the triangles a little bit further out so that I can make this guy more bounded, we can see here's a rare snapshot of the entire antipedal of the blue triangle, and I'm showing the parabolic locus of x2. Okay, and of course, as P is moved outwards, this parabola, as we saw before, turns into a line when P is exactly on the incircle. So here's the line locus of x2, okay, and it becomes a hyperbola otherwise. So as I move this guy outwards, it's a hyperbola. Here are the foci of the hyperbola, so forth and so on. Okay, now what's germane to this new video here is the locus of other triangle centers. So now let's investigate. Let's place P on the circumcircle, and I'm going to turn P to the first quadrant over here. And instead of looking at this nice hyperbolic locus of x2, let's look at the locus of x3. And then this first really strange locus, which I had never seen before, materializes itself. I'm calling this the death ray, okay, of the antipedal triangles. What do I mean by death ray? This is a locus that shoots off as a laser from P into infinity in the direction that, so you have in the direction of the common center. Let's turn off these medial lines, the common center and P. Right, so I have this laser ray, and x3 is on the laser ray. Look at that. So the circumcenter of my antipedals lie on a... Is this a semi-infinite line? Actually has another branch to it, and we can see this branch if I scale this guy outwards. Hopefully there will be this other branch over here. Okay, so what's actually happening is that this death ray is actually shooting off to infinity along a straight line, and as I rotate my triangles, it reappears on the bottom here. Okay, so this is suggestive that this is actually a degenerate two-branched object, such as a hyperbola, and we can see this hyperbola materialize itself, or this two-branched object materialize itself when we, for example, so if we actually make P go in and out of the circumcircle, I remain with this two-branched locus object, right? But let's go and place, so for example, if I'm on the inner, okay, in the inner one, I get the inner one, okay, I'm still with two branches, or is the okay? So actually, when I am on the inner, when I am on the incircle of my family, I do believe the second branch disappears. Okay, so for the special case where P is on the incircle, the second branch disappears, suggesting, again, I still have a degenerate two-branched object, such as a hyperbola, but one of the branches has disappeared. If I move P further in, do I get a reappearing second branch? Yes, I do get the reappearing second branch. So I have this sort of degenerate case of this, through and through piecewise linear locus of x3, which is already quite surprising. But in the case where P is actually on the incircle, only one branch appears, and then when I go further out, then I go back to two branches, and so forth and so on. Okay? Now notice that that second branch never seems to want to touch the incircle. Okay? Now what are these two branches? Are they part of another family? So let's actually apply an affine transformation here and see what happens to this locus. So let's go back to the more canonical situation where I have two branches and P is on the circumcircle. And now I'm going to apply an affine transformation, and you're going to see that I lose conicity. I lose this conic, or this degenerate conic configuration. And let's look at what's happened. So I have this strange curve over here that seems to be shooting off to infinity along two preferred asymptotes. And when I scale this guy out, I can see that the other branch seems to also not be anymore just a line. It's something strange. Let's apply more, a bigger, an even bigger affine transformation. Let me actually move this guy up by a larger amount. So yeah, so you can see here that now I have a curve that is no longer collapsed. Okay, so the phenomenon around x3, it seems, is that if I have no affine transformation, I go back to the equilaterals, this weird non-conic first branch of my curve, high degree curve, is going to actually collapse to a line. Okay, so I guess the salient phenomenon here that we could talk about is that over a family of equilaterals, okay, and only when the affine transformation is the identity, we're actually getting this collapsed piecewise two-branched linear locus for x3, and that's quite nice. What's happening to x4? So the system is telling me this is not a parabola, but it is a conic. Is this conic a hyperbola? Yes, it is. Okay, and forgive me for these two incorrectly drawn foci. Sometimes there's problems here in my focus location algorithm, and I have to fix this bug. So obviously the foci of this conic are going to be here. What happens if I apply an affine? X4 does not survive the affine, so it's only a conic exactly at identity affine transformations. And if I actually now play around with the position of P with respect to the circumcircle, if I go outwards, if P goes outwards, yes, I remain a hyperbola, and now my foci are being drawn correctly. Oh, that's interesting. Oh, no, that's an interesting phenomenon. If P is outwards, the locus of x3 remains a conic, and one of the foci of this family of hyperbolas is stationary at the common center. So that's quite unexpected, right? So I have the other focus moving around. When P is exactly on the outer conic, it is likely that I'm just not drawing this correctly, but that this focus remains here, just by continuity, right? Because if I perturb this guy outwards just a tad, actually outwards, yeah, isn't that what I did before? Yeah, so if this guy goes outwards, at some point, let's see here, so this doesn't look exactly on top. Yeah, so that doesn't look like it's exactly on top, okay? So it doesn't look like it's exactly on top. And what could be happening is that, yeah, I'm losing some numerics here, and it could be that this is actually a conic where one of the foci is exactly that point when P is on the circumradius. But for now, let's just appreciate the fact that I have a family of hyperbolas, right? I have a family of hyperbolas. And then when P enters the incircle, I continue to have a family of hyperbolas, okay, are becoming more and more distal. And then what happens when I go inside? When I go inside, and I'm on the inner here, okay, so that's nice. The locus now of x4 on the incircle, when P is on the incircle, is a parabola. The focus of this parabola is not necessarily something directly visible, so it would be nice for us to calculate what that is. And then what happens if I continue on, or inward? I am now what? So I'm a parabola over here, and as I go in, do I go back to being a hyperbola? Yes, I go back to being a hyperbola, so that's quite interesting, right? So if P is on the incircle, it's a parabola, and if P is inside, it's back to being a hyperbola. So is this thing ever an ellipse? Is this thing ever an ellipse? I don't think it's ever an ellipse. Oh, it is an ellipse here. Okay, so I have three phases again. I have to bring back my the incircle of the medial, and it looks like this thing wants to be an ellipse if P is now inside the Spieker circle. Okay, so X3 is quite complex. X4 is quite complex in the sense that it has these phases, right? This inner one goes through, it's a hyperbola, it's a parabola when it's here, and then it remains a hyperbola, which is surprising, and remains a hyperbola. So hyperbola, 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 parabola here, okay? And then it goes back to being, if my calculations are correct, a hyperbola. And then when it enters this point here, and when it's exactly here, let's put it exactly here, 0.25. Oh, okay. What's happening here? Where is it? Okay, so when P is exactly on the Spieker circle, the locus of x4 is one straight branch of a hyperbola. And then it's going to turn into an ellipse. It turns into an ellipse. Okay, now let's look at x5. It should be doing similar things. I'm not going to go into too much detail here, but we can just very quickly scan what x5 could be doing, starting with P exterior. This looks like a hyperbola. Looks like one of the foci of the hyperbola is falling pretty close to a point on the Spieker circle. Yeah. So let's now bring P closer to the incircle. Looks like that focus is moving a little bit. At some point, I'm on the circumcircle, and I'm a hyperbola that is tangent to the circumcircle at P. And then as I go in, I remain a hyperbola, right? Let's just check that. I remain a hyperbola. Focus is still moving. And then when I'm on the incircle, I'm a parabola. Now the focus is not in a harmonious place, it's right here, but the locus of x5 is a parabola, much like the locus of x4 was a parabola, right? And x3 was a straight line, it was a degenerate parabola. But the locus of x4 is a parabola here, x5 is a parabola as well, okay? And then when I move inwards, continue to move inwards, I'm now, I believe, again a hyperbola. Yes, and then when I cross this other chasm here of being exactly on the Spieker circle, I'm back to being a parabola. So there are two parabolas in this family. That's quite interesting, right? I'm back to being a parabola here. So I can be a parabola if P is on the Spieker circle or on the incircle for the x5 locus. And then when I go inside Spieker circle, I'm now an ellipse. Okay, all right, so in the next video we're going to see phenomena of anti-Stephens connected with the Simedian point and some of the Fermat and isodynamic points. See you on the next video.